In this video, I will talk about the physics behind the roller coaster ride. So let's say now you're going to design a roller coaster. What should be the minimum speed at the top, or at the bottom, or on a horizontal level? That's the thing I'm going to discuss about in this video. And I've chosen one particular numerical to address all the problems. So in this particular problem, which is a roller coaster ride, the car and the rider are moving in a vertical loop. The radius of the vertical loop is 15 meter. That's the radius. And we are interested in now, the only given information is the radius, which is 15 meter. And now what should be the minimum speed at the bottom to make it a complete vertical loop? And what should be, if this is the minimum speed, what is the speed at the top? What is the speed at the horizontal level? We're going to calculate. First thing, we're going to start at the top, at this top. So let's draw the free body diagram at the top. And here we are assuming the roller coaster is moving along this way, the counterclockwise motion. Okay, so the speed at this point, or the velocity at this point, is tangential, which is shown by this arrow. The weight at any point is always vertically the downward. So this is showing the weight. The track is providing a normal force to the rider or to the car, and the normal force at this point is the downward. The N stands for the normal force and T means the top. So now these two forces, NT and mg together, is providing a required centripetal force. Let me tell you one thing. A particle or any object cannot move into a circle without having a force. There must be some sort of force which makes them to move into a circle. For example, the earth is moving around the sun, and the gravitational force of attraction is providing the required centripetal force. And in this particular example, it is now this normal force and the mg, the weight, is together providing the required centripetal force. And what is the formula, or what is the equation for the centripetal force? If you recall, that's perfectly fine. Otherwise, I'll write it down here. mv squared over r is the formula for the centripetal force. Centripetal force. So now let's write down the equation now. So at the top, the NT, the normal force, mg is providing the required centripetal force. And we're going to solve it for the velocity at the top. So what we'll have is NT multiplying r on both sides and dividing by m. So this is what we get. And we are interested in finding out the minimum speed. For the minimum speed, the normal force has to be 0. So when you plug in the normal force is 0, then we get the minimum speed equals to square root of gr. And we know the radius is given, which is 15 meter, and the g value is 9.8, and the speed we get is 12.12 meter per second. That's the minimum speed. What happens if the roller coaster does not have this speed at the top? It won't make a complete vertical loop. It will fall down. Okay, so if you are an engineer, you should consider all those sorts of things. Okay, so it has to have a minimum of this speed, and here we're ignoring lots of things. Okay, this is an ideal situation, ignoring the air drag, ignoring the frictional force, lots of things we're ignoring. but but theoretically or ideally this has to be the minimum speed, and below this speed the car would not able to make a vertical loop. Now let's do the same thing exactly at the bottom now. So again, draw a free body diagram. So the velocity at this point is again tangential, and it is along this way. If I draw a tangent at this point, then that gives you the direction of the velocity, and Vb is the magnitude of the velocity, which is the speed at that point. The weight, as always, is vertically downward, and at this point the track is pushing you upward. So in this case now, the required centripetal force is provided by again Nb, the normal force, and Mg, but the normal force and the weight this time is acting in two opposite directions. So Nb minus Mg provides the centripetal force. The negative sign is simply stands for because the weight is in the downward direction. So let's write down here. So at the bottom, Nb minus Mg is equal to mv squared over r, and then we solve for the normal force at the bottom. This is it. Now we're going to apply for the conservation of energy. Again, let's come back here. It doesn't matter where you are at this point, at the top, at the bottom, horizontal level, or at any other point. The total energy is conserved. It does not change where you are. The total energy has to be exactly the same. In this case, the total energy includes the kinetic energy, and the potential energy, GPE I'm calling. This is the gravitational potential energy, and this is the kinetic energy. And if we add them together, these two energy has to be exactly the same at any points. So we're going to use the conservation of energy now. So applying principle of conservation of energy. So this is at the top, and this is at the bottom. So at the top, we have this is the kinetic energy, half mv squared. That's the formula for kinetic energy. Kinetic energy formula is half mv squared, and the potential or the gravitational potential energy is mgh. So if we choose this as our reference line for this case, then this is the height. So the potential energy at the top compared to the bottom is mg, and the height is 2r, which is the radius or the diameter. In this case, 2r is the diameter, mg 2r. So this is the kinetic energy at the top, this is the potential energy at the top, and as we have chosen the bottom as our reference line, so this it has only the kinetic energy. Now in order to have the minimum speed, so setting up the Vt as a minimum, and we already have solved the Vt minimum is a square root of gr. So I'm just plugging this Vt into this equation, half m, and Vt square should be gr, which is gr, mg2r as it is, half m vb squared. Now this is the minimum speed. That's the minimum speed required, because we have plugged in the Vt minimum. And the mass cancels out, so it doesn't depend upon the mass. As you can see here, if we solve it, what you get is a square root of 5gr. That's the minimum speed required to make a vertical loop. And in this particular value, if you plug in, what you get is 27.1 meter per second. If it is below 27.1 meter per second, the car would not be able to make a vertical loop. It will fall down and it will be disastrous. So now let's again think about the horizontal at this point. We are again going to use the conservation of energy, and as you can choose the reference point at any point. So let's compare the total energy at this point and the total energy at this point. The total energy at this point has to be equal to the total energy at this point. And I'm choosing this as my reference level. If I choose this as my reference level, then this height will be R. And at this point, it has the kinetic energy and the potential energy corresponding to this height. And it will have only the kinetic energy. Okay. So at the horizontal level, this is the kinetic energy now. Kinetic energy. And potential energy is, this is the gravitational potential energy. Why only R? Because we have chosen this as my reference level, so that at the horizontal level it has only the kinetic energy, half mvh squared. And again, I'm plugging Vt. When Vt is minimum, then the formula for Vt is a square root of gr. So just plug in into this equation. So Vt squared would be equal to g times r, mgr, half m vh squared. Now once you solve it, you'll get vh is equal to 3gr. Plug all values, you'll get 21 meter per second. So as you can see, the speed at the different point is the different. So if you want to make a complete loop from the bottom, then you have to start at 27.1 meter per second. If it is 27.1 meter per second, then it will make a complete vertical loop, and it will keep looping around, provided there is no friction or there is no other damping. Alright, so this is it for the roller coaster ride physics problem. And again, if you have any questions, write down your questions in the comment section below. And do not forget to like, share, and subscribe the channel.